So this is going to be a demonstration of how we solve rational equations. So a rational equation is just an equation that has fractions in them, and remember those fractions have variables. So I'm going to write out the steps for how we do this, and it's going to be a lot of steps, but I think it's better to have a nice list of things that we have to do to solve these problems. So what are the steps? So step one is going to be to factor all denominators. Factor all denominators. Step two, find all the bad answers. Now, what are bad answers? So bad answers are the answers that aren't really answers. They might seem like they're answers, but as soon as you plug them into your equation, you get something that's undefined. So I'm just going to say we're going to find which x values make any denominator 0. So if it makes the denominator 0, we know that it's undefined, and so that can't really be a solution to your equation. Okay, step 3. We're going to find the LCD. Now the LCD is just going to be the product of all the powers of all the factors, right? Of the greatest ones. We did this in the adding and subtracting rational expressions. So we talked about how to find the LCD. Step 4. Once you find the LCDs, we have a nice little trick with fractions, which is if you multiply by the LCD, you can clear all the fractions. So clear all fractions by multiplying the whole equation by the LCD. Step 5, solve the equation. So when I say solve the equation, remember there's actually two types of equations you might get. If it's linear, then remember to solve means just to isolate the variable. And if it's quadratic, remember quadratic means that it's degree at least 2, or equal to 2, sorry. If it's quadratic, move to one side and factor. Remember, linear leads to one answer and quadratic leads to 2 answers. But step 6, one of the most important parts. Why did we find those bad answers before? Because any of the answers we get now, if we see that they're actually bad, we throw them out. So throw out the bad answers and put a box around the remaining solutions. We might only have one, we might have 2. Either way, you're going to have either one solution or 2 solutions or possibly no solution. So this is how we write our answer down, either like this or like this or like this. Alright, so let's do some examples here. We're going to start off not so bad, and then we'll get harder as we go. So we're going to solve the following. B over 18 minus 4 over B equals 1/3. Step 1 was factor all the denominators, but there's nothing that can be factored here, so we just jump to step 2. Step 2 is to find all the bad answers. Remember, we have to find where the variable can be 0 on the denominator, or where we can get a denominator of 0. So in this case, the bad answer is going to be b equals 0. This is a bad answer, because if you plug 0 in, you'll get 4 over 0, which is undefined. Now, what is the LCD? Well, we have an 18, a b, and a 3, and so 18b would be the lowest common denominator. So now I'm going to do step 4, which is clear all the fractions by multiplying the whole equation by the LCD. So I'm going to multiply every term by 18b. Oops, sorry. Don't want to write that negative twice. What do we have left? So on the first one, the 18's cancel. We're left with b squared. Minus, on the second one, the b's cancel. We're left with negative 18 times 4 is negative 72. And on the third one, the 3 and the 18 cancels. We're left with 6. We have 6b. So notice that this is in fact a quadratic equation. So I'm going to move everything to one side. I get b squared minus 6b minus 72 equals 0. So now I try to factor the left side. I notice this factors into b minus 12 times b plus 6. And so I get my two solutions. From the first one, I get b equals 12. From the second one, I get b equals negative 6. And notice none of them are bad answers, because the bad answers were b equals 0 only, and none of these are 0. So both of these are solutions. Okay, so let's get a little bit tougher. Not too much tougher, but a little bit tougher. I want us to solve the following. 3 minus 7 over x plus 7 equals x over x plus 7. Now the denominators are already factored, so when it says find the bad answers, we just have to see where the bottom can become 0. And notice if I put x equals negative 7, that would make the bottom equal to 0. So this would be my bad answer. I'm going to store that to the side for now. So now what is my LCD? My LCD is just x plus 7, since that's actually my only denominator here. So I'm going to multiply every term by x plus 7. What do I get? So on the first one, distribute the 3, I get 3x plus 21. On the second one, the x plus 7's cancel, so I'm left with minus 7 equals. On the third one, the x plus 7's cancel, and I'm left with an x. Notice this is a linear equation, which is nice, because that'll make this easy to solve. I'm just going to combine like terms here. I get 14 equals negative 2x. Divide both sides by negative 2. I get x equals negative 7. But before I box my answer, I look up here and I realize, oh wait, this is a bad answer, isn't it? That means I throw it out, and so there are actually no solutions. Yes, this case does come up. You have to practice so that you don't forget throwing out the bad answers. Most students forget about the bad answers entirely and just do the problem, and you don't want that to happen to you. Okay. All right, let's do another example. Going to get tougher this time. I want us to solve the following. 1/2 minus 1 over a plus 3 equals, 9 minus a over 2a squared minus 18. Alright, well, this is not factored. So the bottom of the first two are factored. Can't do anything with those. But the third one we can factor, right? So we can take out a 2 first. We get a squared minus 9. And then that's the difference of squares, so it becomes a plus 3, a minus 3. So what are the bad answers going to be? Well, we have a negative 3. And we also have a positive 3. Either of those would give us 0 on the denominator. So that makes them not allowed. Now, let's write down our LCD. Our LCD is going to be 2 times a plus 3 times a minus 3. So I'm going to multiply each term by this. Every single term. So on the first one, the 2's cancel. What are we left with? Well, we need to multiply this out to see. A times a is a squared. A times negative 3, but then positive 3a, so that's gone, minus 9. On this one, the a plus 3's cancel. We're left with negative 2 times a is negative 2a. Negative 2 times negative 3 is positive 6. On the third one, everything cancels. We're left with 9 minus a. So this is a quadratic equation, right? We have an a squared. So we're going to move everything to one side. First, let me combine my like terms. So negative 9 and positive 6 gives me negative 3. Move everything to the left. I end up with a squared minus a minus 12 equals 0. So now I have to factor the left side. This becomes a minus 4 times a plus 3 equals 0. And set each factor equal to 0 and solve. I've got my two answers, but then I look up here and remember, wait a minute, I've got a equals negative 3 as a bad answer, so that's not allowed. So I throw out a equals negative 3, so my only answer is a equals 4. Alright, we're going to do one more. This is going to be the toughest one. We're going to solve the following. Negative 3 over 10a squared plus 20a minus 80 equals a over 5a minus 10 plus 1 over 2a plus 8. So I'm going to start by factoring the denominators. So this one I can pull out a 10. I get a squared plus 2a minus 8. And then two numbers that multiply to negative 8 and add to positive 2 are positive 4, negative 2. So we get a plus 4, a minus 2. This one I can take out a 5, I get a minus 2. And this one I can take out a 2, I get a plus 4. So what are my bad answers here? Well, I have a negative 4 and a positive 2, right? These are my bad answers. Now, let's write down the LCD. The LCD is going to be 10, a plus 4, a minus 2, since all the others go into that. So now I multiply every single term by this giant LCD. Kind of annoying to write, but trust me, you're going to do a much better job if you write everything out. We have 10, a plus 4, a minus 2, and then we still have an a over 5, a minus 2, plus 10, a plus 4, a minus 2, times 1 over 2, a plus 4. Now's the fun part. I get to do my canceling. So first this goes away with this, and I'm left with just negative 3. On the second one, an a minus 2 with an a minus 2, and then a 5 with a 10 leaves me a 2. So what am I left with? Well, I also have an a here. Let's not forget. So it's actually, if I can bring the a over here for now and cross it over there. So 2a times a plus 4 is 2a squared plus 8a. Now over here, the a plus 4 is gone, and then we have a 10 over 2 that gives me 1 and 5. So 5 times a minus 2 is 5a minus 10. Again, much nicer to look at, right? So now all our fractions are gone. So we combine our like terms. On the right, we have 2a squared plus 13a minus 10. Notice this is a quadratic, so I'm going to get everything to one side and factor it. So I get 2a squared plus 13a minus 7 equals 0. So now I have to factor this. So how does this factor? Well, let's see. I have a 2a here and an a here. So I know I'm going to have a 7 and a 1. It seems like I have to have a plus 7 and a minus 1. Let's see if that works. Positive 14a and negative a, yes, that works. Equals 0. So I set them both equal to 0, and I see what I get. So for the first one, I get 2a minus 1 equals 0. And if I solve that, a equals a half. For the second one, a plus 7 equals 0. I get a equals negative 7. Notice that neither answer is bad, right? We only had two bad answers, negative 4 and positive 2. So these are both okay answers. So that's how I write my work. Okay, so I hope this was informative, and thanks very much for watching. Hope to see you guys again.